Hey everybody, Alex Miller here. I'm with Aaron Rinehart, CTO and co-founder of Verica. How you doing today?
I'm doing fantastic.
Yeah, great. You're a bigwig in a kind of new field with an exciting name. Is that correct?
I guess it's maybe it's a big field now. It's getting there. Definitely chaos engineering for sure.
Yeah, can you just tell everybody a tiny bit about what's that about?
So chaos engineering is becoming an emerging practice at companies, all small and large. But originally began at Netflix. But it's the idea of proactively introducing turbulent conditions into a distributed system to try to determine the conditions by which a service or system will fail before it actually fails.
You think like the cloud is a place where you could talk about, chaos engineering and like your philosophy of how things can go wrong that people might not be able to see?
Yeah, there's no story more relevant than to start at the beginning. The beginning is where Netflix began. So Netflix, believe it or not, a lot of people when I talk about chaos engineering, they're like, "Oh gosh, Aaron, like we can barely do the DevOps. We can barely, barely figure out the cloud. That we can't do a mature practice like chaos engineering." Well, chaos engineering actually began during Netflix's cloud transformation from the data center when they used to ship DVDs. You remember that?
Oh
Like,
yeah,
right? They
that's
still actually
interesting.
do that, believe it or not. They still actually ship DVDs. I found out, but
That was a nice service.
yeah, but actually, it was when they moved over to streaming on Amazon Web Services. So what was happening was they started building out their streaming services. This is the same time when Reed Hastings changed the culture of Netflix. They were going to hire the best engineers. We're going to pay the market rate. We're not going to hire brilliant jerks. All these different things, right? The culture was kind of a big wave at the time. Anyway, so they went for it, started building out this streaming service on Amazon. What happened was is that like at the time they were building it, they AMIs were just disappearing. Amazon Machine Images would poof, where'd it go, right? And it seemed to be a feature at AWS at the time, and Netflix is like, well, crap, that can't be happening like when we're streaming movies because customers will have a bad time. Like if the service goes down, they're not going to pay $12, $20, whatever a month for that service because it's unreliable. So what they did is they decided to make their services resilient to for that kind of failure mode. So one fourth they built their services to be resilient to that failure mode. And what they did was a way to actually test it. No tool about chaos engineering would be fit without talking about Chaos Monkey. So Chaos Monkey did during business hours. What it did was is it would introduce pseudo randomly. It would pick a service and bring down an AMI. What it did was it wasn't just causing chaos, right? What it did was it put a well-defined problem in front of an engineer of a service, right? The well-defined problem being that my service can be exposed to this failure mode during business hours, during operational hours. I need to design my failure modes, my retry logic, whatever I need to, however I need to code this to be resilient to this failure mode. So it turns out the more well-defined problem you can give an engineer, they solve it, right? And
Yeah.
that's really what chaos engineering is about. It's about proactively. So we have this misunderstanding often of what we think the system is in our heads, because
Hmm.
especially in the cloud. The cloud, AWS is if you don't know what complexity is, try opening up the console of AWS services. There's like 300 services. What do I use? What do I use it? There's already. I mean, AWS is great. Don't get me wrong. It's just like it quickly it's more than a human can mentally model and capture and keep in their head. So what chaos engineering, what you do is you develop a series of hypotheses, right? And you say, I believe, you know, I've designed a system for when X occurs, Y is supposed to be the result, right? That's how I believe in my paradigm of how the system operates. I believe that's how it is. And what we do is we actually ask the computer that question. We introduce the failure mode X and determine whether or not it can handle that much latency. Let's say it was it would say our timeout, our SLO, our service level objective was 200 milliseconds. Well, let's introduce 199 milliseconds. Let's see if it can actually handle that much latency because you said 200 milliseconds, right? and we observe the system to ensure that it actually exhibits the behaviors that we thought it did. Yeah.
Yeah, that's interesting. That reminds me a lot of this risk estimation approach in cybersecurity, where you kind of simulate all these weird events, or maybe the Nate Silver, like where do Nate Silver's projections come from? He simulates all the things that can go wrong with the polls. Is this vaguely the right idea?
Well, on the security side, I mean, like on the security side, what we do is it's not really a simulation per se, right? It's actually a failure injection is the technique, right? We inject the failure in the system and we observe the results. And so on the security side, like I started off with, I wrote a tool called Chaos Slinger several years, almost 4.5 years ago. And what that tool did was it introduced a misconfigured unauthorized port change in AWS. Now, that is a very simple failure mode that we've been solving for 30 years in security. A firewall has kind of solved that problem. So what we did, our assumption when I was at United Health Group is that our firewall would immediately detect and block that kind of behavior, right? And somebody could have an unauthorized port change or a misconfigured port for several reasons. It could be that somebody didn't understand how network flow works. It could be that somebody entered the wrong ports. It could be that somebody entered the ticket wrong for the change to be applied. Humans, like, those damn humans. But it's those humans that actually create the security. But here's the thing is that we believe that the firewalls that we had in AWS would immediately detect and block that kind of change. It turns out it actually didn't. So what we were doing with Chaos Slinger is we were pseudo-randomly looking for AWS EC2 security groups that had to allow there's a tag that said chaos engineering is okay. So we would either introduce an open or closed port where it wasn't already open or closed, and then we would turn it off. And then the idea was the firewall should immediately detect and block it. But turns out that only happened about 60% of the time.
Oh wow!
Yeah, right. So like something we're banking on, we expected it to happen, to be caught, but it turns out there's a configuration drift issue between our commercial software AWS and our commercial and non-commercial software. So we fixed it. Remember, this was proactive. There's no war room. There's no incident. There's no outage of a service. Nobody's freaking out, right? We found this problem proactively. We fixed it. Second thing we learned was the cloud native configuration management tool caught it and blocked it every time. So the thing we were barely paying for was better than the thing we were kind of banking on and paying for a lot of money for. So that was the second thing. The third thing is we didn't have a whole lot of faith in our monitoring solution. It was kind of a homegrown solution for security. I wasn't expecting an event to be correlated from the logs that came from the configuration management tool in the firewall to correlate alert to our SOC. That actually happened. So I was like, wow, great. This thing actually works. Cool. Okay, so the event went to the Security Operations Center. Well, the analysts got it. They didn't know which AWS it came from, the non-commercial one or the commercial one. And we're very new to the cloud at this point in time. But remember, there was no war room, no incident, right? So we're able to, as an engineer, you could say, well, we can map back the IP address and figure out where it came from. Sure, that could take you 15 minutes, could take 30 minutes, could take 3 hours. If source NAT address and SNAT is applied, it intentionally hides the real IP address. So you could be hunting around. Meanwhile, United Health Group is losing $1 million a minute. Right? Like, that could be a lot of money for 3 hours.
Real quick, in addition to the book, which I'll link below, what's the kind of 15 seconds? I love it. I want to get started playing with this. What should I do?
Well, honestly, the best place to get started now that we have, this was the main body of knowledge from O'Reilly that we wrote. It came out almost a year ago. There's also the Security Chaos Engine O'Reilly book that I just released with Kelly Shortridge. That both links will be in the. I'll send up both links. But read the book. The book has accounts from Slack, Capital One, from banks to healthcare. It'll give you an idea of kind of how to get started, like what are some things you should consider in building a program. It will kind of help you figure out, and navigate the space. So it doesn't seem as ominous.
Cool. Well, thank you very much.
Thanks for having me.